In this screencast, I'm going to solve a triangle given side, side, side using the law of cosines. As you can see in this example, I'm given side A is equal to 20, side B is equal to 25, and side C is equal to 22. That's why it's called side, side, side. When I say solve, I mean I'm trying to find the missing measures. The unknowns are the measure of angle A, the measure of angle B, and the measure of angle C. Now, when using law of cosines, it can be remembered in a couple different forms. The first form is you can take any three letters. Start with the first one. We'll start with A. Square it. And then it's equal to, you take the other two letters, B squared plus C squared. Subtract 2, repeat the B and the C, B times C, times cosine of the letter that's alone over here, A. So I could, reiterate that pattern with any three letters. This form of the equation is useful when given side, angle, side. In this case, that's not what I'm given. The reason that it's useful for side, angle, side is because in this form, what's alone over here is a side. Okay, so I would have no unknowns on the right-hand side. I could fill in B, C, and angle A. But here I've got side, 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 so I'm going to put in A, B, and C, and my unknown is going to be the angle over here. And equations are easier to evaluate when the unknown is isolated on one side. You could do it no problem by plugging in 20, 25, 22, 25, 22, and then getting the cosine of A by itself. But I find that some students find it easier to isolate cosine of A first. So to do that, I'm just going to follow order of operations. I'm going to subtract. I've got A squared on this side, and I'm going to subtract B squared, subtract C squared, and then divide by negative 2BC. So this is just the same formula rewritten so cosine of A is isolated. So when you're using side, 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 you might find it easier to use that form. But if you'd rather just remember one form, you can just remember the top one. I'll leave that to you. For this example, I'll use this form here in the box. So why do I have A first? Does it matter which angle I find first? No, it doesn't. It makes no difference. But I'll go ahead and find cosine of A first. So I'm going to plug the sides into the equation. Cosine of A is equal to 20 squared minus 25 squared minus 22 squared divided by negative 2 times 25 times 22. It's good to always check that, if I'm finding angle A, that I've got side A is the positive one in the numerator, and that side A is not one of the two sides in the denominator. It's just a good thing to check and make sure you're doing it right. Now, I could try to type this all in the calculator in one step, but I find that some students just get a little confused doing that. So I'm going to break it into multiple steps. I'm going to start with just the numerator, 20 squared minus 25 squared minus 22 squared. I evaluate that. That's the numerator. I go back to my equation here. Now I want to divide that by this product, the product of these three numbers. And this division bar says that you're going to completely evaluate the numerator, then completely evaluate the denominator, and then find the quotient of those two numbers. So I need to make sure when I put this in the calculator that it goes in parentheses. I can just hit divided by, and it's going to take my previous answer and divide it by my input. I have to put it in parentheses. If I don't, it'll just divide by negative 2 and then multiply by the other two numbers, which is not what I want. So again, make sure you remember the parentheses. That's numerator divided by denominator. So cosine of B is equal to that ratio. Okay, right here. Okay, so I know the ratio. I want to know the angle. That's when I hit second cosine. Okay, I checked earlier and I made sure I was in degree mode. I could type in 0.6445, but then I'd be approximating, and I want to approximate as little as possible. The calculator is approximating here for me, but it's going to go out several decimals. So I'm just going to type second and then hit the negative button, and that puts my previous answer there. It saves me a little bit of typing, and it's also more precise. Hit enter, and that gives me angle A. Angle A is 49.87 degrees. It's the approximate measure of angle A. So I can fill it in up here. And I'm 1/3 of the way done with this problem. I'm just going to do the same thing for angle B or C. Doesn't matter which one I do first. I guess I'll go ahead and do B, keep alphabetical. And you might be tempted to use law of sines here, and sometimes it'll work and sometimes it won't. It's probably harder to remember when it will and when it won't, so I think you're better off just using law of cosines only in side, 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 and side angle side. Don't use law of sines in side, side, side problems or side angle side problems. If you do, sometimes you'll run into some ambiguous case problems where you're putting in side, side angle information and there's multiple triangles that exist. So to avoid that confusion, just don't use law of sines for side, 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 or side angle side. So for B, I'm going to make sure 25 squared is first, minus 20 squared, minus 22 squared, divided by negative 20. Fix that. It should be negative 2 times 20 times 22. So that's what's going to go in the calculator. 25 squared minus 20 minus 22. And that's my numerator. Again, I want to take that and divide negative 2 times 20 times 22. And I had to put it in parentheses to make sure I find the product and then divide the numerator and the denominator. So that's what cosine of B is equal to. So I'm going to take second cosine, because I know the ratio and I want to know the angle. Anytime an angle is your unknown, make sure you use the arcsine function. And put in my previous answer. Save me from having to type all that in. And that gives me angle B. Angle B is about 72.89 degrees. So here's angle B, or I'm sorry, that's angle A, and here's angle B. And all it's left to find is angle C. So I could use law of cosines again, or I could add them up and subtract from 180. So I guess I will make sure I rounded right. You know what? I rounded up and I wasn't supposed to. So let me fix that. That should be 72.88. And I guess I'll add them up. Instead of using law of cosines again, I'll add those together and subtract from 180. So those add up to 122.75, and I want to subtract that from 180. And I get 57.25 degrees. So that's the measure of angle C, or the approximate measure of angle C. 57.25 degrees. And I've solved the triangle.